Period B, Organizing the Elements, from pages 160 to 166. Dante, Arcese, Mike Geraghty, and Jake Belham.
I'm Dante Arcese, and I'm going to talk to you about organizing the elements in Mendeleev's table. By the year 1700, only 13 elements were identified. Chemists believe there are more and even assign names to some. The first chemists organized elements into groups by their properties. Dmitri Mendeleev published a table of the elements. On Mendeleev's table, elements were organized by their atomic mass. There were open spaces left for new elements to be discovered.
Hi, I'm Mike Geraghty, and I'm going to be talking to you about today's periodic table. In 1913, a scientist named Henry Moseley determined the atomic number of each element, which is the number of proteins it has. This is why today the periodic table is arranged by order of increasing atomic number. There are 7 rows in the periodic table called periods. The grouping of elements this way makes it so rows and columns of elements in the periodic table share common properties. The periodic law states that there is a repetition of physical and chemical properties of elements arranged by order of atomic number. For example, helium, neon, argon, krypton, xenon, and radon all share common chemical and physical properties. And that is today's periodic table.
Hi, I'm Jake Belham, and I'm going to be talking about metals, nonmetals, and metalloids. Most periodic tables are organized like this one, with parts of period 6 and 7 placed below the table to make it more compact. Each column or group has a label. The US go by the label in red, and Europe uses the ones in blue. The black label is a universal standard, created by the international use of pure and applied chemistry. The elements are also organized into 3 broad classes. In the yellow are metals. About 80% of the elements are metals. Metals are usually good conductors and reflect light very well. All metals are solids at room temperature except for mercury. Many metals can be drawn into wires and can also be hammered into thin sheets without breaking. The nonmetals are shown in blue at the upper right-hand corner of the table, except for hydrogen. Most are gases at room temperature. Nonmetals are poor conductors and also will shatter if hit with a hammer. This makes nonmetals basically the opposite of metals. The green elements on the right are metalloids. This means that under certain conditions, a metalloid may have properties like a metal or it may behave like a nonmetal.